Today's lesson is on section 7.1, the first section in chapter 7, factors and greatest common factors. So we're bringing it back to some stuff that you probably learned in either elementary school. I know my 9-year-old daughter in 3rd grade, she's been going over it, and definitely my son that's in 5th grade. So you first experience in elementary school, definitely in middle school. So it tends to be an easier lesson, just being that you're reviewing something that you had already learned. As this chapter progresses, we're going to be using this one skill throughout the entire chapter. So first of all, what we have to do is what's called prime factorization. This is where you break a number down into only its prime factors. So to remind you what a prime number is, that's a whole number with only 2 factors, itself and 1. So some examples of prime numbers I have written down here are 2, 3, 5, 11, 23, 31, 67. Many of them are odd, because if it was an even number, after the number 2, every even number is no longer prime. 2 is the only one that is prime, because every other one 2 goes into. So there are no even numbers other than the number 2. Some of them, as they get larger, you have to maybe test out on your calculator and keep testing out numbers. I even have to do that with some larger numbers, just because I don't know all of the factors just by looking at a certain number. So that's what a prime number is. So now into prime factorization. Now there's a couple ways to go about doing this. I'm going to focus on one where we do simply what's called a factor tree. So in a factor tree, what you want to do is you want to break each number down into its prime number. So to get there, so you're going to start off, make 2 little branches. And for the number 60, I got to think of 2 factors that multiply together to give me 60. I don't want to use 1 and 60 because that's going to bring me right back to where I am. So I want something else. You could do 2 and 30, 3 and 20, 5 and 12. I'm going to go with, how about 6 and 10 is what I choose to do. You could choose anything, anything that multiplies together to give you 60. So there's about 4 or 5 different combinations you could pick. It's going to give you the same exact answer that I'm going to get. It's just you're going to take a slightly different route. So now 6 I need to break down because that's not prime. 2 numbers to get multiply together to give me 6. I'm going to say 2 and 3. And for 10, I'm going to say 2 and 5. So now this is broken down. 2, 3, 2, and 5. Those are all prime numbers. Now I just need to spruce this up, and I need to write it very, make it look pretty. I have 2 number 2s, so that's going to be 2 squared. You write it in order by the base. So notice I wrote the 2, then the 3, then the 5. It has nothing to do with the exponent. It has to do with the order of the base, so the 2, the 3, 5. If you write something like this, you will get it wrong because that is not written correctly. It has to be written in order from least to greatest according to the base. All right, let's try 32. 2 numbers that go into 32. 8 and 4. 8's going to break down into 4 and 2. 4 will break down to 2 and 2. And then this one will break down to 2 and 2. All right, sometimes it helps to circle them only so you see them all. It also helps that once you get down to this point where you think you have it broken down to its prime numbers, take the half a second it takes to type that in the calculator, 2 times 2 times 2 times 2 times 2, and make sure you get 32. Because sometimes you might your eyes might play tricks on you and you might add in an extra 2, or maybe you leave one off, and then that'll cause you to get the whole problem wrong. The last thing I do is spruce this up, and I need to write it as a power since there's multiple 2's, and this would be 2 to the 5th power. That's the prime factorization of 32. All right, let's do 124. Now, I don't know any big numbers, but I do know that that is even, so I do know that 2 goes in there, and it goes in there 62 times. 62 would be 2 and 31, and 31 is prime, so I'm done. It's 2 times 2 times 31, which would be 2 squared times 31, and that would be my answer. If 31 was able to be broken down, I would have gone further with that, but that's all I had for that one. Now, we're going to use the prime factorization as a method to find factors, common factors. But first, let's talk about what a factor is. Factors are numbers that divide evenly into a given number. Factors are what you multiply together to get that number. So here I have listed out the factors of 12 and the factors of 32. As you can see, the factors of 12 are 1, 2, 3, 4, 6, and 12. Factors of 32 are 1, 2, 4, 8, 16, and 32. It's not always easy to think of them in numerical order or necessarily write them in numerical order. You might just start writing what comes to you, what numbers divide evenly into there. But if you can, after you do that, you want to rearrange them so they are in numerical order, because then you can clearly see what the common factors are. So my common factors, these are the pink ones. They are 1, 2, and 4. We're not really concerned about the common factors. We're concerned with the king of all factors, and that is the greatest common factor, the GCF. And in this case, the largest number that they have in common is the number 4. So the GCF is 4. So when you're asked to find the GCF of a pair of numbers, there are 2 ways to go about doing this. The first way is what we just did 2 seconds ago, where you're finding the factors of each number. So factors of 24. All right, I've got 1, 2, 3, 4, 6, 8, 12, and 24. Now I have to think of factors of 60. Okay, 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Now I'm going to look for the largest one that they have in common. The largest number they have in common, we've got 1, 2, 3, 6 is in common, 12. 12 is my GCF, so that's what I would write down as my answer. So that's the first way you can go about doing this. The second way is we could use prime factorization. Now, just above, I did 60 a second ago, but we'll do it again. This time, just to show you, I'll use 2 different numbers. We'll do 5 and 12. This would be 4 and 3, 2 and 2. So this is 2 squared times 3 times 5. Now we'll do 24. Factors of 24. I'm going to choose 4 and 6. 2 and 2, 2 and 3. This is 2 cubed times 3. Now, to come up with the GCF from the prime factorization, you need to gather what they have in common. So what they have in common, what they both have, the bare minimum of what they each have. So they each have at least 2 2s and a 3. So now I'm going to multiply this out. 4 times 3, and I get 12. So as you can see, I get the same exact answer had I written out the factors. You pick whichever way that you want to do it. Sometimes the factor way, the first way that I did it, can be a little bit tedious. If the number is large and it has a lot of factors, it can become a little bit tedious rather than just breaking it down to the prime numbers. But again, it's going to be your choice, whichever way you'd like to do that. All right, let's do 160. Now, we just did 60, so I'm just going to copy those down over here real quick. Factors of 60. So we had 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. All right, now for factors of 100. I've got 1, 2, 4, 5, 10, 20, 25, 50, and 100. So from there, let's see what my GCF is. They've got 1 in common, 2 in common, 5 in common, 10 in common, 20 in common. 20 is going to be the winner here. So my GCF is 20. All right. If you wanted to do prime factorization, you've got 60. Again, this is now the 3rd time we've done 60. I should have picked some more exciting numbers here. So I have 2 squared times 3 times 5. 100. Let's see. I can do 10 and 10. 2 and 5. 2 and 5. So that would be 2 squared times 5 squared. Now remember, you want to do what they have in common. So they both have 2 squared, and they both have at least 1 5. 100 has 5 squared, 60 has 5. What they have in common is just 1 5. So I'm going to multiply this out. 4 times 5 is 20. So again, I got the answer whichever way that you want to go about doing it, but that's how you would do finding the GCF. Now, finding the GCF when we've got some monomials, basically when we have the we got variables mixed in there. Now for the number part, you're going to find the GCF of the two numbers. Again, you can pick whichever way. Factors of 3 would be 1 and 3. Factors of 6 are 1, 2, 3, and 6. So I can see that the number portion of this answer, GCF, is going to be 3. Now, for the variables, it's how many they have in common. The 3 has 3 x's, the 6 has 2 x's. They only have 2 x's in common, so it's x squared. You want to take the smaller amount because they both have to have, it's at least how many they have. So that one's 3x squared. Next one, 18 and 27. So I'll do this with prime factorization just to show you a different way. 18 breaks down into 2 times 3 squared. 27, 3 and 9, 3 and 3 is 3 cubed. So what do they have in common? They have 3 squared in common, which is 9. That's the number portion. Now for the letter portion, they've got 2 G's in common. They have only 1 H in common, and they do not have any J's in common. So my answer is 9 G squared times H. Okay, in this one, 16, factors of 16 are 1, 2, 4, 8, and 16. 9 is 1, 3, and 9. Notice the GCF here is 1. So as far as the numbers are concerned, the first part is going to be the GCF is 1. Okay, now 16 has A's, 9 has a B. So they don't have any variables in common. So my GCF is simply put, it's just 1. All right, the last type of problem you're going to have are word problems, and we are going to go about finding a GCF. So in this first word problem, it says Garrison is creating a web page that offers electronic greeting cards. He has 24 special occasion designs and 42 birthday designs. The cards will be displayed with the same number of designs in each row. Special occasion and birthday designs will not appear in the same row. How many rows will there be if Garrison puts the greatest possible number of designs in each row? The greatest possible number of designs, that's the GCF. Not only am I going to have to find the GCF, but then I got to find how many times that goes back into those numbers. So my two numbers are 24 and 42. So this was special occasion and 42 was birthday. So I need to find the GCF of 24 and 42. I'm going to use a factor tree, prime factorization. This is 2 cubed times 3. 42 is 6 times 7. 2 times 3 times 7. So what do they have in common? It looks like they only have 1 2 in common and 1 3 in common. So the GCF is 6. Now that's not my answer. All that tells me is there are 6 cards in each row. The question wants to know how many rows there are going to be. So now I'm going to take that number 6 and I'm going to divide it back in. 6 cards per row of special occasion. So 24 divided by 6 is going to give me 4 rows of special occasion cards. Now let's see how many birthday there are. 42 divided by 6 is 7. So there's going to be 7 rows of birthday and 4 rows of special occasion. When I add those together, 4 plus 7, the total amount of rows is 11. So not only are you finding the GCF, but you do have to go and divide it back in. These will always come out to be whole numbers. They're not giving you anything crazy where you're not going to have whole numbered answers. All right, let's do this last problem. Adrian is shopping for a CD storage unit. I doubt you guys even have a CD anywhere around, but that's what people used to play music after records. Then we had cassette tapes, and then there were CDs. Now everybody just downloads the music, but okay, we're dealing with this problem. Adrian is going to store all her CDs. She's got a collector's edition of all these CDs at her home. She has 36 CDs of pop music artists and 48 CDs of country music artists. She wants to put the same number of CDs on each shelf without putting pop music and country music CDs on the same shelf. If Adrian puts the greatest possible number of CDs on each shelf, how many shelves does her storage unit need? So my two numbers are 36 and 48. Again, I'm going to go with factor tree. So this is 2 squared times 3 squared. 48, let's do 6 and 8, 2 and 3, 2 and 4, 2 and 2. So I got 4 2s and the number 3. Now, what they have in common, they have 2 2s in common and a 3 in common. That's going to give me 12. What that tells me is that she has 12 CDs per shelf. Again, that's not what they asked. They asked how many shelves is she going to need. That is if she puts 12 per shelf. So I'm going to divide this by 12, and I get 3 rows of pop music. And I'm going to divide this by 12, and I'm going to get 4 rows of country music. For a total, 3 plus 4 is 7 total shelves. I wonder if you can still even buy a CD storage unit. No, something we'll have to go on eBay for. Adrian's going to have to go shopping on eBay looking for a CD storage unit. But regardless, she needs a total of 7 total shelves.